I've got it going pretty good right now. Just spinning the alternator with the output of the alternator 3 is 70 milliamps, which is what I had before, and 120 volts input. Now let's say we short out the coils on the alternator. Now it goes up to 90 milliamps from 70. So the dead short on the alternator. The alternator now has been rewired so it makes about 15 volts AC. 15 volts AC, because ultimately I want this to power a inverter. And then the 120 volts out of the inverter will power the motor. Okay, so here's the dead short. It draws, what was it, 90 milliamps. Now, let's put a ammeter across it as the dead short. I call this to crowbar. So I'm crowbarring it with an ammeter in AC. 20 amps, should be about 840 milliamps. It is, 840 milliamps. That's good. What I did is I put 3 coils here in series, 3 coils here in series, and then I paralleled the coils. And I also, it has bifilers, and I hooked up the bifilers in parallel. So it's making a lot of amps now, at least for me, 840 milliamps. And it's making about 14.5 volts, this alternator. So let's look at the voltage real quick. Just a minute. Okay, it hit my target, about 15 volts. It's just what I wanted. This is in AC right now. I'm thinking I need to make a full-wave bridge rectifier out of Schottky diodes, because this is not going 60 hertz. It's going about 240 hertz. But anyways, I got it at inverter voltage. And my little statpower inverters will run this motor at 420 milliamps and 12 volts. So coming out of here, I have 840 milliamps if I short it out, and 15 volts. So that's all good. Also, there is the run cap phase. It's not affected very much when it's turning this. I could still be pulling power out with those series transformers, the vectoring thing, from the run cap phase. I'll show you what that makes right now. Looking at the run cap phase, it has 156 volts in it. The meter across the run cap. And it has 230 milliamps circulating, coming from the L3 line into the cap. So that's the VARS that's lurking in the run cap phase. Now, let's short this out over here. Let's short out the 6 coils. 3 are in parallel with the other 3 for that 15 volts. So we're shorting this out now. Now what does it say? The voltage across the run cap has gone down to 146, and the current circulating has only dropped 20 milliamps to 210. So to me this means that I can still be playing with all this and taking power out of here besides what is coming out of here, the alternating. Let's see, so I was filling up this cap with what comes out of the full-wave bridge, and let's do that next. Hold on. Before I start filling up these super caps, 80 farads or so, let's fill up this cap. It's 2300, 150 volt cap. And let me put a voltmeter on it, just 1 minute. Okay, I have the cap right now at 1 volt. It's being fed by this full wave bridge rectifier in DC. AC legs across the output of the alternator, okay? Typical thing here going on. Now, nothing ever seems to go to plan. Now watch when this is 2500 UF, 2300 UF cap. Now, I wanted to stabilize it. I'm hoping it would stabilize about 15 volts. But watch what happens when I fill up this cap. It zooms way out. So that has me worried about putting what's coming out of this alternator into an inverter. So let's put this into filling up this super cap instead. There we go. It's the alternator goes through a full wave bridge. Full wave bridge in DC fills up this super cap, and it's going up about this rate. It's pretty good. I've seen worse. And let's look what the draw is while it's filling up the super cap. 1 moment. Okay, the draw goes up to 90 milliamps while this alternator is chugging up this super cap. And here's the rate it goes. Not too bad. Now, the idea is to plug this into an inverter, have the inverter run the rotor. And I did not film it, but I took the output of the DC output of this and shoved it into the inverter without the inverter, any load on the inverter. And the red lights went off and the beeper was going. So I don't want to sacrifice my statpower inverter right now. So everything's going good. When this gets up to like 15 volts, 15 volts, then I can plug the inverter in. See how it goes. So I'm going to put this on pause and wait for it to get up to about 15 volts. Probably take a few minutes. Okay, hold on. While I'm waiting for it to fill, I'll show what's going on. Here's the air gap between the rotor magnets and the coils and the ferrite core in there. 5mm thick ferrite rod, about 2 inches long or so, fairly long. And there's 8 coils, all the same geometry as the 8 magnets. And it's making AC because the rotor magnet here hits the coils, the rotor magnets hit the coil over here, north facing, and then in alternating fashion, the rotor magnets hit the other side of the coils here, also facing north. And so it's boom, 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 and it makes AC. And that is the design of this. And you notice the rotor magnets and the rotors are quite thin. The idea is that it'll kind of cut through the lens, breaking kind of like a knife. But that's just a theory. But anyways, I have very thin rotor magnets. They're neodymiums. They're 20 millimeters wide. And the thickness of this rotor is thick. A little thicker, actually. So now I only have 6 coils because I figured out at this speed and how the coils are, I make about 5 volts per coil. So 5, 10, 15, and then I parallel them. And the video before this, you saw the draw go down when I connected the bifilar coils that all of these are in parallel, the 2 wires of the bifilar parallel. So these are all connected in parallel now, the bifilars. And I have 3 coils in series here for 15 volts, 3 coils over here for 15 volts. And this coil on top, and there's one in the bottom, I'm not doing anything with that. So 8 coils, 6 of them are working as generating coils. And we are up to 10.3 volts. Now, I changed the amperage input from the grid to milliamps. And now it says it's drawing 104 milliamps right now, which is good. Yesterday it was 120 milliamps or 140 milliamps, but now it's about 104 milliamps. And this is while it's filling up this big cap. So let's disconnect filling up the big cap. And now it's drawing 93 milliamps. Let's connect filling up that big cap, and it's drawing 104 milliamps. That's not bad at all, really. Okay, I'm going to put it on pause again. Also, I tried different size run caps, both with it loaded and unloaded. And the 4UF is what it needs to be. It's the best. And I also put some caps in parallel across the AC feed line, and I couldn't get that to help at all. Probably what I should do next is run this not from the grid, but from my one of my statpower inverters. Here's a little one. Burnaby, BC. I've been there. When I was a kid, we always go up to Canada and we play the Canadians in soccer. We stay overnight at their house. We'd all pair up and then we'd play a game the next day. I've been to Burnaby a few times. The Canadians used to beat us, but then we got better and we started beating them. So what do we got here? 10.78. Okay, I'm going to put it on pause again. Okay, checking the super caps up to 11.29. It goes up that fast. So I got a few more minutes, probably about 10 or 15. So let's go over here. What I'm going to do with this microwave oven transformer, I got the low voltage windings out. You see how thick they are. And this one, it goes to about 9.5 volts, maybe 10 at 120 volts into it coming out. And so what I did, advice of Hector, is there'll be these windings here and shunt bars and stuff here. And so you can see the amount of space you have. That much space in there. A little over a 1/4 inch high. You can pack some more windings on the low voltage side, so you can have more output in volts from the low voltage side. So I want to get this up to, like, 14 volts would be nice. And so I did this already, this hand wound, and I stuffed this in there. And so I got a couple more volts out of it. But you know what I'm going to do? I'm going to take thinner gauge wire, not such thick wire, and fill this with some other wire that's about 18 gauge instead of 14 gauge, whatever this is. And then I should be able to get the voltage on the low voltage side up to like 14 volts or something. And I'm sure someone's going to say you shouldn't connect thick wire to thin wire. But what I'm thinking I'll do is I'll put an AC cap across this, and then put an AC cap across what I'm going to wind in here. And maybe I will put a full wave bridge on it too, and then put a full wave bridge on this too, and then connect the DC outputs. something like that. Because it would be nice if I could just have one transformer. When I have two transformers, because they aren't exactly the same, there's some dephasing going on. But it'd be nice if I could put a single transformer in series on the L3 line from the rotoverter and have like 14 volts coming out of that can go right into that supercap bank or something else. So I'm going to play with this while I'm waiting for the volts to go up in that supercap bank. Okay, I kind of cheated here, but I like to do this. When I made all these bit transformers, I would wind parallel winds, multi-filer, and then after I'm through, I connect them in series 8ing. So this is a bundle of 8 wires. It's about 18 gauge wire, kind of thick. And then I put this in there. Get it down there. I can get it down in there better. So look at all those winds in there. Okay, let's go see what's going on back here. Oh, almost 12. Okay, I'm going to put it on pause again. You know, I want to take a day off from this or come back tomorrow. And I'm just going to hook up this little statpower inverter right now. See if the light comes on. So let's see. That's all I'm going to do. I'm not going to try and loop it right now. I'm not ready for that. Okay, here we go. I'm going to hook up the statpower. Hope it doesn't smoke. It's only 12 volts, so it shouldn't. There we go. It's hooked up. Yes, the light is on. Let's see what voltage it makes. Just 1 minute.